going to require you to really make sure you have quite a few things memorized. And so additionally, you're going to want to have, your notes out from the previous lessons to make sure we're kind of keeping track of things. So we're going to start with the evaluating, and then I'm going to come back and hit that coterminal. So we're going to just work on that evaluating piece first, and then I will come back for coterminal. So a couple of things that we need to take a look at is that if I have a circle that I draw out on the X and Y axis, or a Cartesian plane, and I look at going out 1 unit from the origin. So if I go out 1 unit from the origin, so that means I'm going to draw a circle, and everywhere I draw that circle, that distance would be a radius equal to 1. So even over here when I'm looking at it on the triangle, right? And so if I get to any point on that triangle or on that unit circle, so if I go anywhere here, I have to go along the x-axis however far I go, and then I have to go up the y-axis however far I go. So then that ordered pair would be x comma y, right? So this ordered pair here would be x comma y, which also represents the legs of our triangle. And then the hypotenuse every single time would be equal to 1. And so I know from the previous lessons that sine theta, so SOHCAHTOA, is the opposite side over the hypotenuse. So that's where we get this definition here, the y value over the r, right? Because here's theta prime, reference angle. So if I go opposite, which is my y value, over my hypotenuse, which is r. So we're just using a different definition. I guess it's the same definition. We're just using different labeling. There, that's what I want to say. Different labeling, same definition. So now we're going to call the opposite side y, and we'll always go from the origin for theta prime. So then y over r is the same as opposite over hypotenuse. And so one cool thing about this is because the radius is always equal to 1, we can also say then that sine theta is equal to the y value whenever the radius is equal to 1, which is going to be quite a bit. So sine theta would be equal to y. So if sine is the y value, that means whenever I go up on the y-axis, right, that means I would be in a section where sine would be positive. I need to know that. So where is sine positive? Whenever y is positive. When is y positive? When I go up. So when would sine be negative? Sine would be negative when I'm going down, because it would be when I head down the y-axis, because sine is the y value. So then let's take a look at our cosine. And so I know cosine theta from previous lessons is adjacent over hypotenuse. So adjacent to theta prime would be x, right? So that would be x. And then over the radius, which is equal to 1. So then what can we say about cosine theta? If the radius is equal to 1 and we're on a unit triangle and a unit circle, then cosine theta would be the x value. And so if I need to know when is cosine positive, well, it's going to be positive when the x value is positive. So if I go from the origin, I have to head to the right to get to positive values of x. So that would be over here. And if I want to know where cosine is negative, that would be when I head in the negative x direction, which would be over here in quadrants 2 and 3. And then finally, for the last one, tangent. So SOHCAHTOA, right? So tangent is opposite over adjacent. So over here, so opposite over adjacent. So the opposite side is the y value, adjacent is the x. So that's where we get tangent of theta is equal to y over x. Well, unfortunately, x and y are not the radius, so that means we can't simplify it anymore. Other than what we can look at is we know that y over x is a lot like our slope, isn't it? Because our slope is, rise over run, or delta y over delta x. So if I want to know where is tangent positive versus negative, I want to know when my slope would be positive. So if I'm at my origin and I want to draw a positive sloped line, I would go this way, right? Wouldn't that give me a positive sloped line because y over x? So that would be where tangent is positive. But if I want to draw, say, a negative sloped line, then that would be going this direction, right? Isn't that a negative slope? And then that's where tangent is negative. So how am I going to remember where sine is positive? Well, I need to know sine is my y value. So I go up for positive sine, down for negative sine. I also need to memorize cosine is the x value. So if I want to get to positive values of cosine, I'm going to go where x is positive, so head to the right. And then when is cosine negative, I will head to the left to get to negative x's. And then what else do I need to know? When is tangent positive or negative? So because it's y over x, or a lot like our slope, I will go into these two quadrants for a negative sloped line, right? That would give me a negative slope. Or I could go positive, go the reverse way. That would give me that. Okay, so with all that said, a lot to memorize. Okay, so key things so far that I need to know is that the sine is the y value, cosine is the x value, and tangent is both. Very important. The other thing I need to know is my 30, 60, 90 triangles. So if I have a triangle that has a 30-degree down here, I know across from the 30 is 1/2. Adjacent to it was root 3 over 2, and the hypotenuse was 1, right? So that was from previous lessons. So if I were to draw in a 30-degree, I'm going to get a thicker pen here so I can see this a little better. So let's go here. So if I were to draw in a 30-degree angle, so say right around there, so let's call that 30 degrees, then I know to go from 30 degrees to this ordered pair, I have to head right root 3 over 2 and up 1/2. So what did I do? I went over root 3 over 2 and up 1/2. And that's the same thing here, right? So if I go over root 3 over 2 and up 1/2. So that means the ordered pair for a 30-degree is root 3 over 2 and then comma 1/2. I'm going to get that off of the double black line there. So this ordered pair would be root 3 over 2 comma 1/2. So let's take a look at a 45-degree. So what if we have a 45-degree line? So let's call this one 45 because that looks pretty close to being in the middle, right? So this will be our 45-degree. So what was that ordered pair, or what would that ordered pair be? So from our 45, 45, 90 special right triangle, we know across from that it was 1 over root 2 or root 2 over 2. And it's isosceles, so this will be the same, right? So if I go from the origin, so that would be this dot right here, those would be corresponding, I would go across the same amount as I would go up because it's isosceles. So I would go over 1 over root 2 or root 2 over 2 and up the same amount, right? Knowing my triangles. Because these sides would be exactly the same because it's isosceles. And then finally our last, so we're going to do one more here. So let's do our 60-degree. So it's the same as the 30-60, isn't it? Aren't they? Like the 30-60 is the same, but this time we're going to drop this to be our 60. So I know across from the 60 is root 3 over 2, and then adjacent to it was 1/2. Now, when I say I know, like maybe I don't have it memorized, but I certainly have access to it from the previous lesson, okay? So we're going to do one more here. So we'll call this one 60 degrees. So I'm going to go from the origin, so this is the origin right here, and I'm going to go over 1/2 and up root 3 over 2. So from here, I'm going to go over 1/2 and up root 3 over 2. So the biggest thing that you need to take out of everything I just talked about is you have to have these memorized. Like this is not like, do I know it? Do I not know it? I need to get these memorized. I need to navigate with them. And so this is like what we call quadrant 1. Okay, so this is our quadrant 1 unit triangle. Unit ratios, and we're also going to be playing with these as well. Okay, so you, depending upon your teacher, they may emphasize use the ordered pairs. Some of them may emphasize using the triangles. So just make sure that you can navigate both ways. Okay, all right, so let's go ahead and take a look at this first example. So we'll come back to coterminal angles. So the first thing we want to do is we want to sketch each angle in standard position. So we're going to start with that. So I have 150 degrees, so I know this is 0, 90, this is 180, so it's somewhere between 180 and 90. So wherever that 150 is, we'll say that's 150. and that's from 0. So then part B, they want to say, well, okay, what quadrant are you in, right, for the terminating ray? So this was quadrant 1, quadrant 2, 3, and 4. So quadrant 2 is the one we are in, right? So somewhere between 90 and 150, so there's quadrant 2. And then our part C, they want us to find our reference angle. So remember, reference angle was the shortest rotation to the x-axis, right? So shortest rotation to the x-axis. So let me highlight the x-axis here. So I have to drop that terminating ray to the x-axis. So am I going to backtrack to 0 or move forward to 180? And I'll move forward to 180 to get to that shortest. So for finding reference angle, so that notation we use is theta prime. So I just want to know the distance between 150 and 180. And so I would distance meaning subtract. So I'm going to subtract those two values. And that would get me a reference angle of 30 to 0, 30 degrees. All right, so now we want to find the sine, cosine, and tangent. Well, the way we're going to do that is figure out, okay, well, if that reference angle is 30 degrees, then I could certainly draw in a triangle, right? Like I know my ratios for 30, 60, 90, so let's call that 60 right here. So across from the 30 is going to be 1/2. Adjacent to the 30 is √3/2. And then the hypotenuse is going to equal 1, right? And so again, if I don't know these, I can always, look at previous notes, or I can look at the top of the notes, right? Because we wrote those out as well. So all I'm doing is just kind of following those guidelines. So what's going to be different though is I always want to get direction on here, because I don't want to just say like this is the length is √3/2. I also want to add in direction. Meaning if I head up or down, left or right, I need to indicate that on the sides of the triangle. So when I head to get to this tip of the arrow, so I'm going to travel not along the hypotenuse, but along the legs, I'm going to head leftward, so that would be a negative direction, right? So I'm headed left, negative direction, and then I'm headed upwards, so that would be a positive direction. So I just want to get, positives and negatives on there. So what else do I need to know? So we talked earlier about sine is my y value. So, or opposite over hypotenuse. So that would be 1/2 over 1, and it would be positive, right? Because I have a positive here. Cosine is my x value, right? So the x value is this one over here. So, or adjacent over hypotenuse. So that would be negative square root of 3/2. And then over 1 doesn't matter. And then finally for my tangent, it's going to be the y over the x. So the x, right, so this is my x-axis, this is my y-axis. So this is my x value, my y value, right? So vertical is y, horizontal is x, right? Over the x, up the y. So my tangent is going to be the y value divided by the x value. I can't leave it like that, I have to simplify it. So I'm going to multiply the numerator and the denominator by 2. So those 2's will reduce, and will that, right? Because as long as I multiply the numerator by the same thing as the denominator. So I have a positive 1 divided by negative √3, right? Or just negative 1 over √3. Okay, so let's go ahead and do another one. And again, we're going to come back to coterminals. We'll hit that at the end. All right, so the first thing we're going to do is graph 240 degrees. So I'm going to go ahead and label my quadrantals. So we have 0, 90, 180. We still haven't gotten to 240 yet. 270, there we go. So somewhere between 180 and 270. So we'll draw in that 240 degrees, wherever that would be. We'll say there. And that's in quadrant 1, quadrant 2, quadrant 3. So in quadrant 3. So then after I do that, I want to find my reference angle. I just erased too much there. There we go. So for my reference angle, the shortest distance to the x-axis, right? So I want to rotate to the x-axis. So which way would be faster, right? Like that's always what I'm thinking about. And so here it would be faster to backtrack to that 180. So we're going to go ahead and do that. So to find theta prime, which is my reference angle, I'm going to subtract, because that's a distance, right? 180 minus 240. What is that? 60 degrees. So then my reference angle is 60 degrees. And I just realized I wrote this in the wrong thing. So that is quadrant 3. And then how about that one is 60 degrees. So now I know this is 60 degrees here. So now I'm going to go ahead and I'm going to label the triangle. And I went, which way did I go? To the x-axis. So I want to draw that to the x. And I want to label things. So across from the 60 is root 3 over 2. And adjacent is 1/2. And the hypotenuse is 1. Now I'm not just like pulling this out of nowhere. I'm looking up here to see like what's what, right? So across from the 60 is root 3 over 2. And then always add in direction, right? That's really important. So from the origin, so from here, pay attention to the direction you have to travel to get to the tip of the arrow. So first I have to head left on the x-axis. So the x value is going to be negative 1/2. And then I have to head downwards on the y. So that would be negative, right? So the sine, remember, is the y value. So sine is opposite over hypotenuse, or the y value, so that would be the downward, so that would be negative root 3 over 2. Cosine is my x value. So the x value, this is x-axis, side to side, so my x would be negative 1/2, right? Or adjacent over hypotenuse, negative 1/2. And then tangent is the y over the x value. So my y value was negative root 3 over 2. And then my x was negative 1/2, right? Because the y value was negative root 3 over 2. Cosine was negative 1/2. And then every single time, I'm going to multiply by 2 over 2. So the 2's will cancel, the 2's will cancel. And so I'll have negative root 3 divided by negative 1, which is just the same as positive root 3. Okay, so hopefully we're getting that a little bit. All right, so let's do a couple more of these and then we'll move on to the next phase. All right, so 405 degrees. So we know that's 0, 90, 180, 270. Hey, we're not there yet. How about 360? Okay, and then plus another 90. What is that, 450? I think so, yeah, 450. Okay, so we didn't use the 0 or the 90 because we went beyond that. So I'm going to erase both of those because I didn't use it. And then I know I'm somewhere between 360 and 405. So I'm going to just say somewhere there. And then I want to rotate to the x-axis. So I'm in quadrant 1, even though it's 1, like I went around twice, I guess. So my reference angle theta prime is the shortest distance to the x-axis. So do I want to move forward to the 180 or backtrack to the 360? And so I am going to backtrack to the 360, right? A little bit quicker that way. So theta prime is how far apart they are. And how far apart they are means we have to subtract a couple of things. So I am going to subtract 405 from 360. What is that, 45? Yeah, 45 degrees. So my reference angle is 45. So I'm going to label that. And then I'm going to label the sides of my triangle. I have some stuff in the way here. So again, if I don't know them, right, I need to know my special right triangle. So across from the 45 is root 2 over 2, or maybe 1 over root 2, whichever way you want to work it out. And it's isosceles, so they'll be the same, right, both 45. And then I want to put direction. So from the origin to the tip of the arrow. So I have to head right on the x-axis. So that means the x value is going to be positive root 2 over 2. And then up on the y-axis. So then the y value will be positive root 2 over 2. So sine theta is my y value. So that's positive root 2 over 2. Cosine is the x value. So positive root 2 over 2. And then what is tangent? Tangent is the y value over the x value. So sine was my y, so positive root 2 over 2. and then divided by the x value, which is cosine, positive root 2 over 2. And then I have like over like, don't I? Like the same divided by the same, so that would be just equal to 1. Okay. All right, last one in this kind of category, not like last one, you know. So negative 225, so this would be 0, negative 90, negative 180, negative 270, there we go, right? So negative 225 is somewhere between 180 and 270. So that would be in quadrant 1, 2. So quadrant 2, and then I want to find the reference angle, so theta prime. So shortest distance to x-axis. So would I go to the 0 or would I go to 180? Like which distance is shorter? And it's going to be to the 180, right? And I want to find how far apart they are. Remember now, reference angles are always positive. So then I want to figure out how far apart is 225 from 180. And I'll figure that out just by subtracting them. So that would be 45 degrees. So then now I'm going to go ahead and label. So there's 45. So to get to the tip, so I'm going to head left root 2 over 2, and that is an x value, and it's negative, right? Because the left along the x-axis, root 2 over 2. And then now I'm going to head up along parallel to the y. So then the y would be positive root 2 over 2 because it's headed upwards, and the hypotenuse would be 1. Okay, where am I getting these numbers from? Special right triangles. Okay, so then I know the sine is a y value, and in this case, the y was positive root 2 over 2. The cosine is the x value, so that would be negative root 2 over 2. Always getting that direction in there. Obviously, if it's positive, you don't need to put the plus, but it's a good habit. And then finally, tangent is y over x. So here's my y value divided by, there's my x value. And then I have like divided by like, but it is a positive divided by a negative, so that would be negative 1. Okay, so there you go. So there is just kind of using your unit triangles. And then the last component that we need in this section is coterminals. So I kind of skipped that concept, right? So let's take a look at coterminals since we skipped it. So our coterminal angles are angles who have the same initial side and the same terminal sides, but they would rotate differently. So meaning they go an extra spin around the circle. So whenever we find our coterminal angles, all we have to do is add or subtract 360. So we're not doing radians yet, so we're going to ignore kind of that piece there. Okay, and so we're ignoring that, we're going to be in degrees. So how do we find a coterminal? We either add or we subtract 360 degrees. So we're just going to do a couple of these just to kind of get the gist of that. So we'll start with number 2. Okay, so I'm going to give myself a little bit of space here to do that though. So we're going into that kind of coterminal angle, right? So let me draw in that 240. So for question number 2, they're asking us specifically to find, hold on, sorry, do a little shrinkage there. So in order for us to find a coterminal angle, it said to either add or subtract 360 degrees. So that's what we're going to do. So we have 240. So one of my coterminal angles, I'll just do the first one here, is I'm going to add 360. So that would give me 10, carry the 1, so 600 degrees. So there's one of them. Or subtract, so now I'm going to go ahead and do that. So now I want to take 240 and I want to subtract 360, and that would give me negative 120 degrees. And there are 2 coterminal angles. So what that means is I can go a full 360 and then another 240. That's where the 600 came from. Or I can just start here and I can go just the short distance, which would be, instead of going forward 360, go back 360. So I'm going to subtract it. And so that would give me a value of negative 120. Okay, now let's do one more here. So we'll take a look at number 4. And doing coterminals again. So we're either going to add or we're going to subtract 360. So I can take negative 225, and then I want to add 360. So I'll add that. What's that? So that's the same as 360 minus 225, right? Because 360 is positive, 225 is minus. I'm going to have to do a little extra work here. 135? I think so. So one coterminal angle is positive 135 because the 360 is positive, bigger. Or I can take the negative 225 and then subtract the 360. So a double negative means I'm going to add these together and it'll stay negative. So the negative 585 degrees. Okay, so there's coterminal angles. All right, here we go. Last little bit. So we want to sketch, oh wait, just kidding, not the last little bit. Second thing. Okay, so we're going to do sine, cosine, and tangent, and we're going to do them on quadrantals. So this is a little bit different. So if it's on quadrantals, what we have to do is we have to look at the ordered pair of the quadrantal we're using. So if we go back and we look at, this particular problem, we're not going to be looking at any of these ratios because we're going to be on a quadrantal. So that means we're going to be looking at these ordered pairs here, and then we're still going to be using the ratios that we know. Okay, so sine is the y value, cosine is the x, tangent is both of them. So this is the quadrantal, so we're going to be looking at what are these ordered pairs, making sure we have those memorized or at least figured out. Okay, so let's take a look at this one. So we're going to sketch in standard position. So we're going to go from 0, and we're going to rotate up to 90 degrees. And then I'm just going to kind of darken that so we can see that. And that would be sketched in standard position. And then we want the sine, cosine, and tangent ratio. So that means the first thing I want to know is what is that ordered pair there, right? What is that ordered pair at 90 degrees? So at 90 degrees, that ordered pair is I went over 0 and up 1. So that's my x, that's my y, right? So to get from the origin to here, I'm going left and right nothing, so that would be 0. And then up a distance of 1, because we're always going to have a radius of 1. Now remember, the sine is the y value, so that would be positive 1. Cosine is the x value, so that would be 0. And then tangent is y divided by x, so 1 divided by 0. So 0 is underneath, so that would be undefined. And then we'll do coterminals for this one. So coterminals, I'm going to take the angle that was given, which is 90 degrees. I'm going to add 360 to it, and then I'm also going to subtract 360. So one of the coterminal angles is 450, and then let's subtract for the other. So that would be negative 270 degrees. All right, and then here we go. So same thing. So we're going to do negative 180. So here's 0 degrees. So negative 180, that's going to be going this way. So there's my sketch. And then because it's a coterminal, a quadrantal, we're going to write the ordered pair. So from here, I'm going to go left 1 unit and then up and down 0. So the ordered pair for this quadrantal is left 1, up and down 0. So my x value is negative 1, my y value is 0. So sine is the y value, so that would be 0. Cosine is the x value, and that would be negative 1. And then tangent is y divided by x, so the y value is 0, x was negative 1. So 0 divided by negative 1 is 0. And then we don't need to do another coterminal. Okay, so now we truly are at the end here. Okay, so finally, right? Here we go. So we want to identify the quadrants. So that means our answer is going to be like quadrant 1, 2, 3, or 4, right? So identify the quadrants where the terminating ray for theta can lie so that the equation is true. So when we are seeing this, we just want to know the quadrant. It's saying that cosine of theta is equal to 1/3. So the way we want to think about that is cosine is the x value. And we want to know where could that be where x is going to equal positive 1/3, right? Because remember, cosine is the value of x. So if I look here and I want to figure out where is the x value positive, like where is the x value positive? So the x value positive is over here, isn't it? Isn't this where x is positive? So that would be in quadrant 1, or down here in quadrant 4. Right, so just a reminder on quadrants, this is quadrant 1, 2, 3, and 4. So where is cosine, which is the x value, positive? That's when I go to the positive x-axis, so that would be in quadrant 1 and quadrant 4. And then let's take a look at number 8. So the tangent, so remember tangent is y divided by x, and then equal to -2. And remember for tangent, we want to think of it as slope, right? Because delta y over delta x, or rise over run. So how would I get to draw a negative sloped line through the origin? And I would go this way, right? Wouldn't that give me a negative sloped line? So that means I would have to be here in quadrant 2, or down here in quadrant 4. And then now for number 9, so this one is, so sine theta, so sine, remember, is your y value. So they want to know, where would y either be positive 3/4 or where could it be negative 3/4? So let's take a look at the y-axis. So that's y-axis. So first of all, where would I go to get to positive 3/4? I would go up, right? So it would be positive here or here, positive 3/4. So, right? And then where would I go for negative? So negative, I would go downwards, so here and here. So where would I go to get to either positive or negative values of y? Well, I would go up or I would go down. So that would be everywhere, right? So that would be all 4 of them. So quadrants 1, 2, 3, or 4. And then also I could just look at the very front sheet here, and if we forget, right, this also tells me, where I have positive and negative values for each of the different trig functions. All right, there it is. So that